So hi guys, we are at day 13 of dynamic programming series, and today we are solving a new variety of dynamic programming problem, that is dynamic programming on matrix. And the problem that we are going to solve today is maximal square problem, that is of Leetcode. Okay, so let us look what the problem is. Okay, so let's look to the problem. Given a 2D matrix filled with zeros and ones, find the largest square containing only ones and return its area. So basically we have been given a binary matrix that has 0 and 1, and we need to return the largest square that only contains 1 and return its area. Okay, so let's see the example. Here in 5 cross 5 matrix we have been given only ones and zeros, and the square which has maximum area and it only contains 1 is this particular square, and the area is 4. So we'll return the output as 4. So I think that the problem is quite easy to understand. So let us quickly dive into the approach, that how we can approach this particular problem. Okay, so the problem is a classic example of dynamic programming on matrix. As we can see that we have a matrix and we need to find the largest area. So it is clear that it is an example of dynamic programming on a matrix. So what we can do is we can simplify to find the maximum area of square with the given overlapping area. So by this statement I mean that, let us look into the example. So basically we have areas of 1, we need to find the areas of 1. So what we can do is we can just look at the number of ones that we are getting. So if I have only this particular one, only single one, then what is the maximum area that I can get is only 1. If I move towards the right, then I also have only this one. So what is the maximum area I can get is 1. Similarly, if we move towards the next row, then we can also only get the area of 1. Similarly here also only 1. But if we consider all these 4 ones together, then what is the area, what is the size of the square that I am getting is 4, and the length of the side of the square is 2. So of the square of length 2 I am getting in this particular case, and the size of the square is 4, because all the parts, all the blocks are filled with only 1. So here I am getting a square of size 2. Okay, but now let us move toward this part, that if I am getting 1 but here only this particular block is 0, so can I get a square of size 2? No, I can get only square of size 1 with all of these 1. Maximum size that I can get is only 1, because this particular block has 0, and by this particular because this particular block is 0, so I cannot form a square of size 2. If we move further, here in this particular case also we cannot form a square of size 2, because this particular block has a 0 in it. Now here I can form a square of size 2 because all of the blocks are filled with 1. Right, similarly we can move towards the whole array, and we can see that we can have blocks of size 2 and blocks of size 1. If there is a single one, that it will have size 1, and if there are 4 ones, then we have a square of length 2, and the size which will return, the area which will return, will be 4. Okay, so we can form more squares with size 2, but what we need to return is we need to return the area of the maximum square. We need not to know that how many squares we can form of this particular area. We only need to return the largest area of the square that we can form from only once. Okay, so we need to find a pattern for this particular problem. So if we need to find the largest square at this particular position, that is represented by a question mark, then what we need to do is we need to have the knowledge of the maximum area of the square that is formed just before it, that is this square, just diagonally opposite it, that is this square, and the square that is just above it, that is this square. So we need to have the knowledge of the areas that is formed by these 3 squares. So in this example all the squares were having the area 2. As we can see, all the squares are having the area 2. So what we'll do is we'll just increment in the size, and we'll get the answer for this particular block. If this particular block has 1 in this, so what we'll do is we'll find the area of all the 3 squares, and we'll just increment in this, and we'll find the answer, that is 3. Right, so we have made the observation from these particular example. But what if one of the square has a lesser area? So in this case, in this example, what we have is we have a square of size 2 just above it, we have a square of size 2 just diagonally opposite to it, but we have only square that has size 1 that is just before it. So we do not have a square of size 2 just before it. So what will be the answer in this particular case? In this particular case, we'll have answer 2. So one thing is clear, that if all the squares will have a same area, that what we'll do is we'll just increment it by 1. But if any one of these squares have a smaller area, then we need to take that area into consideration and increment 1 in the size. So what is the observation that we can make from this particular example is that we need to find the area of the square amongst all the 3 positions that we just considered and find the minimum square, that is the size of the square must be minimum of all the 3 squares, and we'll just increment in that size and we'll get the size for this particular ij block. So let us see with the help of this example how we can do this is, we have square of size 111 in this particular case. So what we'll do is we'll just increment in the size 1, and what we can get is we have a square of size 2 here. But in this case we have a square of size 0 here just above this particular position. So we can have a square of size 1 at max possible in this particular ij position. So what we'll do is we'll now frame a DP solution. So for particular position I and j, as we have seen in the given observations that we just made, so we need to find the minimum of all of these 3 positions. The positions are I, j minus 1, I minus 1, j minus 1, I minus 1, j. So we'll find the minimum of all these positions, and what we'll do is we'll just increment it by 1 and fill this particular position. So let us look at the code for this particular problem. So basically we have been given a binary matrix as an input. So what we'll do is first we'll make the n and m as variable, and we'll make the rows and columns in these variables. If n is be equal to 0, then what we'll do is we'll return 0, because this is the base case. If the size of the matrix is 0, then what we'll do is we'll return 0. Otherwise what we'll do, we'll form a vector, 2D vector of n cross m filled with zeros, and we'll make a variable max that will have the size. By size here I mean the size of the side of the square. So initially mx will be 0, so mx will be containing the size of the square. So what we'll do is we'll run a loop on n cross m, and if I will be equal to 0 or j will be equal to 0 and matrix of I comma j will be 1, then what we'll do is we'll fill dp of I comma j as 1, because the first row and the first column can have a square of size 1 at max possible, and in which case if the matrix of I comma j is 1. So I hope you are getting this. If the matrix of I comma j is 1, the maximum square possible at first row and first column will be 1, because it only have one element and no element is above it or just before it, right? So we'll have the square of size 1 in this particular case. This is the base condition for filling the matrix. Else what we'll do is we'll check if the particular position have 1 in it, and if it have 1, so we'll apply the DP formula here that we have just created by observations. And at last what we'll do is we'll find the maximum which we are storing in mx. So we'll find the max of mx and dp of I comma j which we are currently running on, and at last what we'll do is we have got the side, so we'll return the area, that is side into side of this particular square. So I think the problem was quite easy, and now we are at the stage where we are learning to form an iterative solution from the observations that we can make, and we are learning a variety of problems. So that is it for day 13. And the concepts that we have learned today is DP on matrix and how to use optimal structure with memoization in the matrix. So if you have any doubts, any problem that you are facing in dynamic programming, you can always comment us in the comment section below, or you can provide your doubts on the email that we have provided in the description. Please do follow us on the links that we have provided in the description and the problems that we are giving you in the description. So kindly read the description part as well. So thank you for watching the video. Please do like, share and subscribe my channel. Thank you.